Welcome, Form 4, at Maths, past years, SPM. This is SPM 2011, topic coordinate geometry. A straight line x over 2 plus y over 6 equals 1. Now the moment you see this line, we remember from our lower secondary the straight line equation of x over a plus y over b equals 1. This is from our lower secondary, Form 1, Form 2, Form 3. That straight line will make intercept. It will cut the x-axis at point A over here, and it will cut the y-axis at point B over here. And for the equation of x over a plus y over b equals 1, the gradient of the graph m is negative b, the y-intercept, over a, which is the x-intercept. Okay? So if you are given equation intercept, this is called the intercept form, we can get the gradient. We continue the question. And this straight line, it cuts the x-axis at point P and cuts the y-axis at point Q. Okay? What is the question asking? Part A, find the gradient of the straight line. So here, part A, find the gradient m of the straight line. First of all, I draw back. I have drawn back the graph. This is the y-axis. This is the x-axis. Our question have said that this line, this straight line, it cuts the x-axis at point P and it cuts the y-axis at point Q. Now we have to complete the diagram. If you see, a point on the x-axis, the y-coordinate must be 0. A point on the x-axis, the y-coordinate is 0. So here, this is yp. So how do I get the xp? From this equation, what I do is I'm going to substitute that the yp equals to 0. So if I substitute yp, here this yp, I substitute with 0, what am I going to get? This whole thing would become 0. So I would get x over 2 equals to 1. Therefore, x is equals to 2. So the xp is 2. And this information I put back in the diagram. So the coordinate p, x coordinate is 2, y coordinate is 0. Repeat the same thing. The question said that the line intersect the y coordinate at q. Now this q is at point y, and in point y, we know that the x coordinate must be 0. Point on the y-axis, the x coordinate is 0. So this is xq. And how do we get the yq? Again, go to the equation. Now I'm going to substitute xq equals to 0. So here xq I guarantee 0. So this whole thing now becomes 0. So what is left? Y over 6 equals to 1. Therefore the y, of course 6 bring it up, is 6. So this is the yq, which I've already marked over here. Okay, and remember in our equation, x over a plus y over b equals to 1. You watch carefully. The A is the x-intercept. So this should be x over, the x-intercept is 2. So x over 2. And the B is the y-intercept. Y-intercept is 6. So y over 6 equals to 1, which was our given equation. You see? Our given equation. So part A, find the gradient. Because the equation is in intercept form, I'm using the formula gradient is negative b over a. And our b was 6. 6. Our a was 2. So therefore, gradient is negative 6 over 2. Divide, I get gradient equals to negative 3, which is our answer. And don't forget that this gradient, negative 3, is also gradient of the line PQ. Is also the gradient of the line PQ, which we are going to use for the second part. We look at the second part. What is the question asking? Find the equation of the perpendicular bisector of the straight line. So this part B over here, I've written part B. Find equation of the perpendicular bisector. Again, I have drawn back the graph, which here is the y-axis, x-axis. I have drawn back the line PQ with the coordinate P 2, 0, coordinate Q 0, 6. First of all, draw the line perpendicular bisector. Perpendicular means the blue line, it must be 90 degrees over here. This is 90 degrees, the angle. And this is the meaning of perpendicular, that the blue line is perpendicular to the PQ. Second, bisector means this length and this length is the same. So if this length and this length is the same, the point here, of course, must be the midpoint. The point here is the midpoint of the point PQ, which I've already labeled. Now we start. If you remember previous lesson, to find an equation, we need a gradient and a point on the line. So to find equation of the perpendicular bisector, I need the gradient of the line, the perpendicular bisector, and I need a point on the line. And the point on this perpendicular bisector, of course, is the midpoint. The point on the perpendicular bisector is the midpoint here, which I label capital MPQ. So now I need to find the midpoint PQ, which I label as XM, YM, and I need to find the gradient. We do one by one. First, we find the gradient. Now, to find the gradient of the line, that line, if you look here, the blue one, is perpendicular to the PQ. So the line which we want to find the gradient is perpendicular to PQ. And if you remember the notes, when two lines are perpendicular, the gradient of one line is negative 1 over the gradient of the other line. And this gradient of PQ, we already have over here, gradient of PQ, negative 3. So I substitute gradient of PQ, negative 3. Don't forget, negative, negative become positive. So I got the gradient of line, we are looking for 1 over 3. So one part settled. Now we find the point on the line, which is midpoint. And of course, to find midpoint, we must use the formula of midpoint. Midpoint of PQ, the x coordinate of the midpoint is xp plus xq divided by 2. The y coordinate of midpoint, repeat, yp plus yq divided by 2. I have written back the coordinates here, so easy for us. So xp plus xq. xp is 2, xq is 0. Therefore, it is 2 plus 0 divided by 2, which will give us x coordinate of midpoint 1. And then yp plus yq. yp 0, yq 6. So we have 0 plus 6 divided by 2. I'm going to get the y coordinate of midpoint is 3. So second part also settled. I got the coordinate of the midpoint, which is 1 and 3. I got it over here. So point also settled. Now, we are going to take the gradient of the line and the midpoint, substitute in the formula y minus y1 equals to m x minus x1. Remember that the y1 and x1 is the point on the line. In this case, the midpoint. So this y1 is actually yn, and x1 is xn. And of course, the m is the gradient of the line. All we have to do now is substitute. The original y, copy back. Ym, the y coordinate of midpoint is 3. So I have 1 minus 3. And the gradient of the line, 1 over 3. Substitute 1 over 3. The x, copy back. And the x coordinate of midpoint is 1 over here. 1, settle. Now here, because I have two terms, I put the bracket first. You see, bracket y minus 3. And then the 3, I transfer, divide, transfer to the left hand side, becomes times. Of course, on the right hand side, I am left with the x minus 1. And the 3, I times inside. So we have 3 times y, that is 3y, minus 3 times 3 is 9. Right hand side, still the same. Now, equation of straight line is better to make it equal 0. So what I did, 3y, copy back. The positive x I transfer to the left hand side, become negative x. Negative 9, left hand side, copy back. And negative 1, right hand side, transfer, become positive 1. So I have 3y minus x minus 9 plus 1. And of course, negative 9 plus 1 is 8. Negative 8. Negative 1 plus 9 is negative 8. Our final answer, 3y minus x minus 8 equals 0. Which is the answer, the equation for the perpendicular bisector. Thank you. I see you on the next lesson.